good evening. Welcome back to our Day 3 session of International Conference hosted by Team Shakti and Amrita University. I'm Purnima and I will be your host for the session. So moving on, we have here with us Ms. Priyadharshini Krishnan, Engineering Manager at American Megatrends International. Hello Priyadharshini and welcome to ShaktiCon.
Yeah. Hi, Purnima. Thanks for the introduction.
Hi. Prior to this, she has been working on developing tools. She holds a bachelor's degree in computer science and engineering from Madras University. And today, she is here with us to give a session centered all around firmware security. So without any further delay, over to you, Ms. Priyadharshini.
Thanks, Purnima. You saved my introduction time. Thank you. Thanks for that wonderful introduction. Hello, everyone. A very good afternoon to everyone. So I'm Priyadharshini Krishnan, Engineering Project Manager at AMI. So on behalf of AMI, I take this opportunity and thank the entire crew of ShaktiCon for providing us this wonderful opportunity. So today, my session will be mostly around firmware security. So about myself, Purnima has covered. So I completed my bachelor's in computer science and engineering from Madras University back in 2004. And then I joined AMI and I've been associated with AMI for the past 16 years. So I have been into various development roles, right from a system software engineer. I started writing applications that was around firmware development. So writing new environments for firmware development, debuggers for firmware development. So my entire experience is around developing tools and utilities for firmware development. For the past few years, we have been working on implementing security solutions for firmware and software. So with those experiences, we'll have our session where we look at firmware, the need for firmware security, and implementing firmware security solutions. So let me share my presentation. So is my presentation visible?
Yes, your presentation is visible.
Okay. So the agenda for this session is a introduction, what is firmware, and the need for firmware security. And then I'll go through some of our security products. So the reason why I go through these security products is with these products, I'll explain the concepts behind implementing firmware security. So before I start, I'll give a brief introduction of AMI and what we do at AMI. Founded in 1985, and we are known worldwide for AMI BIOS. The mission of us, AMI, is power, manage, and secure the world's digital infrastructure. We have offices in 7 different countries worldwide, and we have roughly around 1,500 employees. Our unique and broad expertise is in firmware. So right from firmware development to security solutions, network and storage management tools. So that's what we do at AMI. About me, I covered this. Firmware. So I hope all of you know what a firmware is, but still I'll go with a small introduction on what a firmware is. So in layman's term, if we have to say what a firmware is, it is known as software for hardware. So it is a low-level software found in the system. It facilitates the communication between other devices and is responsible for the basic input and output tasks. Basically, firmware is the software that powers your system's hardware. So the typical examples that come to our mind when we talk about firmware are embedded systems, consumer appliances, computers, and computer peripherals. Today, the two main firmware components that I'll be touching upon are BIOS and BMC. BIOS. BIOS is a software that resides in a non-volatile ROM chip in your motherboard. And that is the first thing that comes to life when you power on a computer. The basic responsibilities of a BIOS is initialization of various components in your motherboard, and this component hands over the control to the operating system. Next one is BMC. BMC is Baseboard Management Controller. It is basically a service processor and it's capable of monitoring the physical state of servers, computers, or other hardware devices. It also has sensors with it, and these sensors are capable of measuring parameters such as power supply, fan speed, and temperature. So BMC majorly helps us to monitor a large number of devices remotely, and it thereby reduces the operating cost. So this is the basic on firmware. Why we need firmware security? So let's go back 7 years or 8 years. So those times, if you want to develop a firmware, it was not very common. So the firmware developers or the people who understand firmware was very limited, considered a very difficult task. So firmware development or what a firmware does, these things were considered very difficult. That was 7 years back. Fast forward now, firmware development is as easy as any other writing any other software program. So with firmware development becoming more and more easier, the firmware attacks are becoming more and more common. So what happens when your firmware gets attacked? So your unsecured firmware leaves your platform extremely vulnerable to low-level attacks. So without the proper firmware security measures in place, industries or let's take sensitive organizations like militaries or critical government sectors. Without proper firmware security measures in place, these sectors are leaving their sensitive or classified data vulnerable to theft, alteration, and deletion. So if you attack and get hold of a platform, then it means that the entire platform is compromised. Anything you run on that platform is not secure anymore. And compromised firmware is also very impossible to detect without any specialized hardware. So if we look at some of the recent research done by the Information Systems Audit and Control Association, the results are literally very shocking. So 70% of the enterprises that participated in this research, they do not emphasize hardware or firmware security during their lifecycle management, and they feel unprepared to deal with the attack. 50% of the enterprises that do emphasize on the hardware or firmware security during their lifecycle management, they report at least one incident of malware infected firmware. 8% of the enterprises only feel they are fully prepared for a firmware related attack. There were also other major findings with this research. Fewer than 1 in 4 enterprises fully include firmware in their processes and procedures. More than 1 in 3 enterprises are not even monitoring or measuring or collecting firmware data, and they don't even know if their enterprise is doing so. So, firmware security is has started to be considered by enterprises only now. So, we saw why we need firmware security. Now, how do we know that our platform is secure? That's the next step, right? So the firmware that we talked about, BIOS or BMC, these are almost the first pieces of code that get executed in your platform. So we have to make sure that the platform is trusted. So this means that even before the BIOS and BMC takes control, we need something in place that ensures that both this BIOS and BMC or any other firmware that gets control is trusted. So it is essential for every platform to be trusted at boot time, be it data center or be it any enterprise environment. So what do we mean by trust? Platform trust requires validated firmware. By firmware, I mean all firmware. Are you aware of all the firmware running on your platform? I just said two, BMC and BIOS. there are many other firmwares that are running on your platform. Let's take some examples. The network interface, NIC card, that has a firmware in it. The PSU, the power supply unit, that has a firmware. And there might be even some non-volatile DIMMs that are there in your platform that has a firmware running in it. So how do we make sure that all this firmware running inside our platform is secure? And also, with the recent developments in the industry and the security industry, the firmware security trends are also changing very faster. So the use of firmware in the data center has increased as the platforms are becoming more and more complex. There are lot of individual components that require their own firmware. Now, with this increase in the firmware, there also comes an increase in the attack surface. So all these increases, it drives the interest in firmware security. Now, when we are going to implement firmware security or we have firmware integrity, all this gets important. But the underlying thing is we need a deep understanding on the firmware development. Without understanding how a firmware is implemented, there is no way you can implement a security solution for that firmware. Now, when we talk about data centers, obviously cloud deployment comes into the picture, and cloud security also becomes a top priority for adoption. When we spoke to different enterprises, when there was a research conducted with different enterprises and discussions on the barriers and concerns for implementing a cloud solution. So the top barriers that came up in the research for cloud adoption was basically security risks, data loss and leakage risk, and legal and regulatory compliance. And when they were asked about the major security concerns, data loss and leakage, data privacy, confidentiality, these were some of the major factors that came up for adopting cloud solutions and cloud security. So when we talk about security, these three terms always come into picture: integrity, attestation, and assurance. So we know the definition of these terms from an information security point of view. So integrity, in information security point of view, data integrity means maintaining and assuring the accuracy of data over its entire life cycle. In the context of platform integrity means that the platform firmware and software has not been modified in any unauthorized or undetected manner. Attestation. In the context of platform, attestation means the process of validating that the platform is trusted and it maintains its integrity. Assurance is basically a declaration intended to give confidence. So, again, in the context of a platform, assurance means providing the confidence that the platform components are authentic. So, I explained what a firmware is, why we need firmware security. Now, let's go over some of our products where I'll explain you the concepts on how these products implement security solutions. So the first one is CLEPS. This is a cloud environment for firmware signing. So up until a few years ago, firmware source code were signed with keys, and the keys were also kept along with the firmware source code. So storing the keys along with the source code they are meant to protect is a sure way for an attack. So that's where we implemented a CLEPS solution, which is a cloud environment solution where we separate both the keys and the firmware, which is going to be signed with the keys. So I hope you guys know what a HSM is. In case for people who don't know, HSM is a hardware security module. It's a physical computing device that safeguards and manages digital keys, and it performs encryption and decryption functions for digital signatures, and it has strong authentication and other cryptographic functions. Basically, it comes in the form of a plug-in card or an external device. You can attach it to your computer or a network server. Nowadays, there are cloud HSMs available. Basically, it is a HSM that is hosted in a cloud environment. More and more leading names in the industry like Google, Amazon are coming up with their cloud HSM, which you can subscribe and make use of it, and you use the encryption and cryptographic functions provided by the HSM and for your own application development. That is HSM. Now we'll see how a firmware signing happens. So the first step for a security implementation is you need to first sign your firmware. And then we will have the next steps where we validate whether the firmware is trusted or not. So the first step is signing. So in this example, let's take that the project source code is built. Here, the project is BIOS. So I have a BIOS source and I'm building the BIOS source. So the output of this is a binary BIOS image. So this binary BIOS image needs to be signed. Only the signed binary image can be further processed to verify whether it is trusted or not. So in order to proceed for signing, what we do is we take key parts of the binary. They are measured and described by hashes. And the next step is we take these hashes and then go through a signing process. So in this signing process, we have shown a cloud HSM in place. So the private key always remains within the cloud HSM. It doesn't come out of the cloud HSM at all. So that's the strength of the HSM. So we use the private key, we sign the hash, and we create a signature. Now the public key and the signature gets embedded into the firmware. So from now on, when we are going to verify whether the firmware is authentic or not, we are going to take this signature and we are going to verify for its authenticity. So this is how a firmware signing typically happens. So now that we saw how the firmware is signed, we will see how this signed firmware is used and it's validated. So Platfire is one such product which provides platform firmware resilience. So it provides a secure root of trust solution. So what is a root of trust? Root of trust is basically a set of functions that is always trusted by the computer's operating system. So root of trust is a cryptographic platform security solution that is used to validate the boot process, and it ensures that the system's firmware is intact and it attests that the firmware has not been tampered with. So by placing this root of trust into an immutable region on a physical chip takes it one step further, which means hardware root of trust. So hardware root of trust strengthens the system security even more, and it protects the platform from booting with unauthorized firmware. So it protects the firmware from unauthorized modification. If unauthorized modification has happened, it detects that modification and it recovers from unauthorized modification of the firmware. So how do we do that? So here there is an FPGA. FPGA is basically field programmable gate arrays. It's an IC which can be programmed after manufacturing. In this example, we have a lattice FPGA. This lattice FPGA provides runtime SPI monitoring. So let's take, I have the BIOS here. I'm powering on the system. So now what happens is, so we have a hash. So this hash is generated similar to the signing process I explained in the previous slide. So this hash goes to the FPGA. FPGA already has a known good configuration available with it. So it compares and it detects whether this hash is valid. If it's not valid, it is going to recover. So it already has a golden image copy available with this. The golden image is basically a trusted image. So it reflashes the golden image into the BMC. Thereby, the BMC goes into a trusted state. Now the BIOS. The same process is followed for BIOS also. It sends its hash. The FPGA determines whether the hash is valid or not. If it's not valid, again, the golden copy that it has is flashed into the BIOS. Thereby, the BIOS gets trusted. Only when both these pieces become trusted, the system goes on to boot and it gets powered on. Then the control goes to operating systems. So that's how we protect a platform at the boot stage. So we spoke how a firmware can be signed and how a platform can be validated for its trust. Now let's go a step further. How do we implement these solutions in a data center? So True is one such product of us that provides data center security. So providing trusted environment for cloud executions. So this product uses Intel security technologies and Intel security libraries that are targeted for data centers. So when we talk about data centers, this is a typical data center environment. We have workloads. Workloads are nothing but an application or a service deployed on the cloud. And these are the compute nodes where the workloads will have to be executed. So let's just say we have a sensitive workload. By sensitive workload, I mean a workload which has sensitive information. For example, an application that processes the Aadhaar information. That's a sensitive workload. So we cannot run this workload on any node. We have to make sure that the compute node is trusted first before executing our sensitive workload, right? So how do we assure that the workloads are secure? So we'll implement a platform security server. And the job of this platform security server is to trust all the servers status. It tracks the trust status of all the servers, and it also tracks the location status of the servers. Why we are tracking the location status? I'll come to it in a little bit. So let's take a small example. I have a different workloads here. The workloads with exclamation mark means that they are sensitive workloads. They can be run only on trusted nodes. And there is something called as TPM here. So what is a TPM? A TPM is Trusted Platform Module. It's a computer chip that can securely store artifacts that are used to authenticate your platform. So a TPM can be used to store platform measurements, and it helps to ensure that the platform remains trustworthy. Basically, it collects the hashes from all the different firmware components in your computer and stores it. So there is a trust agent. This is nothing but a small service. The job of this trust agent is to collect the current TPM hash information from TPM, and then it gives it to the platform security server. Now, with this hash information, the security server already has a known good configuration with it. So it is going to compare both of them, and it is going to determine the trust status. Only when the status is trusted, the sensitive workloads are going to get executed. The other workloads, the ones with tick marks, that mean that they don't have any sensitive information. So they can be run on any compute task, any compute nodes. They don't need to be run specifically on a trusted server. So in the last slide, I said that the security server will also have and track the location status of the server. The reason for that is data sovereignty. This is one of the legal regulatory compliance when it comes to cloud solutions. So basically, certain countries have these regulations, like their regional data cannot be processed outside their region. So when you deploy a cloud solution, you have to ensure that the regional data that is processed is inside their region. So it has to be done on a server, cloud server that is deployed inside their region. So that becomes very difficult without geotagging. So geotagging the servers means that you tag that particular server with that specific region identifier. So with that, when you have your workloads, you can ensure that your workload is executed only inside that region. So the physical security server the platform security server that I explained in the earlier stage will is capable of doing this. So for example, this workload has to be run only in a server that is hosted in United States. So the platform security server ensures that the location status of the server matches with the geotag of the workload. So if a European Union workload has to be run, it will not be run in the United States server, even though the platform is trusted. So similarly, the workloads pertaining to their region will be executed only in their regional servers. So who benefits from these firmware security solutions? I would say everyone benefits. So people who are looking to make their systems resilient from supply chain attacks, and people who want to attest starting from the hardware all the level up to operating system. Cloud service providers, data centers equipment without a hardware root of trust are exposed to platform firmware attacks, and they risk the security and privacy of their customer information. And enterprise environments with security conscious IT professionals. So enterprise environments that are exposed to platform firmware attacks risk the integrity of personal and proprietary information. So that's all I have. I hope I have given you a glimpse into the world of firmware and firmware security. Thanks again. Thanks for this wonderful opportunity given.
Thank you, Priyadharshini, and thank you for the knowledge that you just shared us. So we have a question here. It's like, are the validations done better in a software than firmware? Like, especially for a region?
Okay, basically the data sovereignty regulations that I explained is basically done at a software level. It's not at a firmware level. Other than that, if you talk about general validations, these are two different things, software and firmware. The first step is a validation of the firmware. So you make sure that your firmware is secure first. Without that, as I said, anything you run on top of an unsecure firmware is unsecure. So even though you have thousands of security measures put into your software, it's not valid if your firmware is not secure.
Thank you. And if we have more questions, please do post it here in either in the Q&A window or in the chat window. So we have a next question is like, you need to keep a firmware validation before software validation. Like, do we have to keep?
Um, as I said, firmware validation is something different and software validation is something different. So you can implement a software validation without implementing firmware security measures. You can implement firmware security measures without software validation also. So firmware security is basically to make sure that your firmware is trusted. And then you can have as many additional validations that you want in your software.
So I think these are the questions we have so far. And thank you so much for patiently answering all the questions which our participants had posted. And it's like, honestly, I mean, thanks a lot for sharing your knowledge regarding the firmware security, like what are the different attacks and the different needs of for firmware security. And also we had looked into like the first steps for implementing the firmware security, as well as AMI's contribution towards the security solutions and all. So once again, on behalf of all our on behalf of our team Shakti, as well as Amrita Vishwavidya, we would like to thank you a lot, and as well as we honestly do look forward your your we hope you will join us for our further future sessions also.
Yeah, thank you. Thank you. So, as I said, this is a whole new world. Most of you might have worked on firmware already, but this is a different world of where you have firmware and firmware development and the security measures to be implemented in a firmware. So, yeah, I would definitely be looking forward to participate in any of the future sessions. And if you have any doubts or anything, please feel free to contact.
Sure, thank you. I'm pretty sure many of our participants will be interested in contacting with you for the further details and all.
Thank you.